So maybe we give Edson and the Cora protocol the stage. And can you introduce yourself first, Edson?
Yeah. Thank you so much, everyone, for having me here. A bit about me. Yes, my name is Edson Alcala. I'm from Mexico, but I'm based in the UK. And yeah, I've been an Ethereum developer since 2017. Yeah, I learned about UMA back in 2020. I think it was before the DeFi summer. I'm sure everyone remember the craziness of the price pumping. And yeah, I was running some liquidators. We Actually, I was running the first disputer, because yeah, the first ever disputer in UMA, it was by me. So I guess you should guys give me a pope, no? That would have been fun. Yeah, I don't think there was a lot of popes in those days. Anyways, yeah, I've been yeah, just following UMA. I think it's a protocol that I fall in love with their design and all the economic considerations. Then I did an online, yeah, I was running an online academy, and I did a course on UMA. Uh, I think looking back, I'm sure it could have been better. But yeah, I just wanted to learn. I did a lot of tools. Actually, I did the synthetic builder, and yeah, just trying to contribute to the community and to the UMA ecosystem. Yeah. Today I'm going to talk a bit about what we are doing at Cora. Cora is decentralized. Yeah, well, the title of the presentation is Developing Decentralized Pricing Models Using UMA, and it's focusing the needs that we have at Cora. So I'm going to start first explaining what is Cora, and then give a bit overview. I won't go into super deep detail, but I have prepared some slides in case there are more questions. But the main idea is to give you an overview of what we are trying to do and why we think UMA is the best solution. So, what is Cora? Cora is a lending protocol that basically allow anybody to borrow stable coins for a fixed set period of time without the risk of being liquidated. More deeply, Cora is actually a structured product. However, we've been packaging this product into lending because we think it's the most widely used case, and everyone knows and feel the pain of liquidations. At least I have felt the pain, especially ones that I had to pay like 1,400 in gas back in the days where the gas was more expensive. But yeah, it was crazy. Um, and obviously the question would have been like, okay, how do you manage to do this non-liquidatable part? And the easy answer is the liquidations, the liquidity providers, as we call it, or suppliers, the people who is putting the capital in the protocol, so borrowers can take that capital, are taking the risk. Um, I'll go more into details how they take the risk, but the easy answer is that we are trying to provide the tools for them so they can basically collaborate together to manage their own risk. And this is a better explanation of uh, how Cora works. So in Cora we have a lending pool, and liquidity providers simply deposit stable coins in this lending pool. So they deposit, and the stable coins goes to the reserves, and then they get a LP token that represents their shares of this particular pool. Then the borrowers can lock their collateral, and then in exchange of this liquidity. So basically, borrowers are borrowing these stable coins, and they simply lock their collateral. So since there is not really liquidations in this system, the LP has they need to have a way to manage the risk. So the first one is the protocol helps them by setting up a LTV, which is the maximum amount, or the maximum amount that a borrower can borrow per each unit of collateral. So one example would be, let's say the Ethereum price is $1,000 today, and the lending pool defines a LTV of 80%. So that means the borrower can come and borrow up to $800 of per collateral unit per ETH. And then The other part is, okay, I'm taking the risk for giving you my capital. How much should I charge you? And that's where the pricing models or price models come into play, because they are used for the lending pool to calculate the fees. Okay, the product is very simple. We are trying to provide a very easy to use experience for borrowers. They simply need to come, they define what is the amount of collateral they want to lock. Then the protocol tells to the borrower, this is the maximum amount you can borrow. And then they choose how much they want to borrow for a fixed period of time. Then they can see a summary and finally get their money. That's it. Okay, now trying to go a bit deeper, and this is to give you a perspective of how we picture this, because in the lending in Cora we have a factory contract, and thanks to this factory contract we can create multiple lending pools. And as you see, there is one stable coin and one collateral per pool. It can even be possible to have multiple collaterals per pool, but that's going to be something we are planning to do in the future. For the moment, the important part is that you imagine and notice that each lending pool can have different price models. And this modularity, obviously, for us, I think is pretty cool, because you can create different lending pools with different parameters and different price models. I think that also gives us a lot of flexibility of what we want to build, but also brings the problem, right? Like, who's gonna maintain these price models and who's gonna define the values? Because, for instance, the block should require like implied volatility or realized volatility. It depends the strategy that the pool wants to follow, perhaps a fixed rate. So yeah, but the important part is that you picture that there could be multiple lending pools, and each lending pool can have a different pricing model. So as I was mentioning, the LPs are taking the full risk, but the idea is to decentralize the risk management of the protocol, in this case per pool, and we see LPs collaborating, trying to find what is the best value for a particular pool, and also which particular price model should they use, and also to manage the price models, because these price models require some external data, and that's the question. So which LTV, which price model? Our goal is to decentralize the full risk management of the protocol, and we think the only way to do it is by using UMA. So when we talk about decentralized pricing models, what exactly are we saying? The whole idea is that anybody should be able to propose changes in a permissionless way, and we are kind of classifying these pricing models because we believe there are some pricing models that don't require real-time data. So there could be perhaps, for example, what is the expected APR of a given validator in Ethereum? The data of this validator doesn't need to be updated every second or every minute. Like it's gonna be like pretty slow. So these decentralized pricing models that we are trying to work with, they don't require immediate real-time data. So it could be, let's say, 1 day delay, or it could be a pricing model that you post every day a value, and it should be fine. It will work. I think this model, this same architecture, could be extended to, for instance, credit scoring. Let's say you want to create a price model that perhaps can encapsulate some logic about the credit scoring of certain parties. This credit scoring doesn't need to be updated every day. So yeah, when we talk about decentralized pricing models, please keep in mind that. And so this is the very simple architecture, actually. We have a price model, and we have a proposer, a disputer, and UMA. And the idea is that the price model is gonna define what kind of information the price model requires. And then the proposer simply observe this price model and say, I want to propose a new value, and I'm gonna pose the receive that I used to calculate that value. And then you simply have a disputer who can observe that particular value and say is correct, is wrong, and if he thinks is wrong, he simply dispute that value. Um, Obviously, there are some opportunities here because let's say the proposer and the proposer wants to stop the protocol of working, and he basically could make a proposal, and the proposal could be wrong and at purpose. But this could be a denial of service attack. That's why we are exploring the possibility to add this fault tolerant mechanism where we can have a queue of proposals, and basically even this person is proposing, the disputer can always dispute propose, but at the same time another party can come and dispute that. So the idea is that this price model is always working, and even if there is an open dispute, the price model is not stopped from working. Why is important this? Because imagine someone wants to stop the lending pool to work, and since the lending pool depends on the price model, basically it will be impossible to the lending pool to work properly. So that's what we are working on right now. And obviously, if there is a dispute, we simply raise the dispute to UMA. Um, some considerations. Obviously, this is where we are right now exploring a bit. We have a call with some of the UMA folks from the core team, and I think there are interesting approaches, interesting ways to do it. Um, for instance, should we restrict or whitelist proposers? This could be interesting because imagine this price model could define a mechanism to people to register, or perhaps the DAO could say, okay, let's whitelist these 5 people and they need to every day propose changes. And if they don't perform their duties, basically they could get a slash or basically punished by that. So I think that could be interesting. The other is just, as I mentioned, if we assign duties to these proposers and they are whitelisted, do we punish them? So that's also something that we're exploring. And then what would be the main basically incentives for the proposer? And I think for disputer is more clear because he could basically earn for behaving properly, but in this case the proposer has needs to have a stronger incentives. And yeah, the whole idea is to, by enabling anybody to come and make changes to the price model, you have fully decentralized management of the pricing model, and then you have a fully decentralized protocol without any yeah, because let's remember that if a person owns or manages the price model, you could argue that this person is basically controlling the protocol, and this is risky. This can have legal implications for the person, and in some jurisdictions this could be very very bad. So yeah, um, I think that's it. Thanks. Do you guys have some questions?
Okay, thanks a lot. That's short and sweet. And there's a few questions I thought of, but maybe I'll open it out to others first. Does anybody have any questions for Edson? Or maybe want more details from Edson?
Yeah, Edson, could you give like one specific real world example of a price model and the what would be proposed to UMA? Like, I'm just a little bit unfamiliar with some of the different price models you're talking about, but if you could
Yes.
maybe walk through like one
So
real world type example, that'd be great.
Yes, one example would be, for instance, this is the position in the Cora protocol. You can visualize the LPs and the borrowers on this. And as you can see, the borrower has a limited downside and unlimited upside. So the borrower basically doesn't have the risk of being liquidated. And the liquidity provider here, he has a capped upside and then unlimited downside. As I was saying, they are taking the risk. So what price model could help to the LP to basically solve this, to manage its own risk? And this would be hybrid price model, or it could even be just an options pricing model. For instance, Black-Scholes. The Black-Scholes, because Black-Scholes basically uh, implicitly calculates what is the probability that the collateral would fall below this limit, below the loan amount. So by using, let's say, Black-Scholes, you could price the fee. Now, one of the problems is that getting the right data for Black-Scholes is very difficult. But for instance, you could use the realized volatility, and the realized volatility could be a value that you update every day. So that would be a clear world example. Black-Scholes updating using realized volatility.
Okay, and so the Black-Scholes rate would have to be calculated off chain, which is why
Uh,
this is a good fit with UMA, or could
yes,
it be calculated on chain?
no, this could be basically you could get it off chain, and then
Yeah.
every day you could basically be pushing.
Okay. Yeah.
The
Interesting.
other another example, it would be, let's say you want to do an interest rate swap, and the interest rate swap price model would be, I have, let's imagine there is a party that has, let's say, STETH, and the STETH will have an APR, let's say 10% annually. Okay, then you lock this, and then the LP will need to know, okay, I know what is the expected return of this asset. Maybe I can charge a certain amount. But this is a value that also needs to be calculated off chain, because the LPs could run I don't know, something off chain process to say, okay, this asset is expected to have 10% annually, but is maybe I can offer loans for 3 months. And I think using my machine learning algorithms, maybe I can assess that maybe I should charge 10% or something for this asset. So he can basically update its own price model, and that when the person comes with the STE, he can pay to that particular person, but he brought the data off chain.
Mm-hmm. Cool. Thanks.
Yeah, Edson.
Yes.
So I just have a question regarding this particular slide. So how often do you think there will be a price proposal with from Cora end, which will need Uma's help? Like for every, is it going to be for every price settlement there is going to be a proposal, or like how is it going to be?
So it would be a proposal every day. So basically, imagine the Cora here. Cora is the lending pool and is receiving requests. I want to borrow. I want to borrow, and then we are using the pricing model. Calculate. So the protocol is using this pricing model to charge, to calculate the fees, and then the borrower is simply getting his capital, locking, and the LP, thanks to this, is in some way is managing its own risk, because the way he manages the risk is, number one, the LTV of the pool, and then how much should I charge for taking this risk. So with the Black-Scholes, we are picturing to be once every day. I think that because it's the realized volatility, so we're picturing once every day could be okay. However, in terms of restrictions with this architecture, I think it would be basically configurable. Like, what is the minimum period on which you can accept new updates? Because that can also have the risk that a lot of people, okay, there was a accepted proposal, and and if, sorry, there is a noise. Yes, so I'm accepting the price model is accepting proposals, but let's say if there is no limitation on the timing, a lot of people could be using the right answer and try to get, if the price model is giving incentives to honest proposals. So basically, it can get drained. So I think we need to have a minimum limit, and then actually, if many people is proposing, they are also taking the risk, because this mechanism with the queue should only take the first correct proposal. So if another person wants to propose again, he is on the risk that if this person did it correct, he wouldn't do it. He's not going to be taken into consideration. Mhm.
Makes sense, yeah. Thanks, Edson.
And
And in the consideration slide, you like basically there was a point that you are figuring out whether you want to whitelist few people or you want to keep it open for all. So regarding
yes,
that, I have some feedback regarding that because we were discussing this about this at a particular point of view, and I think if you keep the proposal process open to all, it would be better because this will become more efficient because if you keep few whitelisted people as compared to open for all based on incentives, if it's open for all, people will try to to do the work faster to get the incentive as opposed to when you have a selected few people whitelisted.
mm,
If you want
yeah,
the mechanism to be efficient and faster, I think if it's open for all, then all the people whenever something comes up, whenever a proposal is up, like everyone would rush to propose the details as soon as possible. So that would make the entire process more efficient and quicker.
yeah, that makes sense. I think that's great feedback, and we definitely gonna do it like that. Mhm. Something that I forgot to mention is that there has to be a period where basically the proposer is putting the proposal, and then there is like a period where anybody can dispute that proposal. And we are actually thinking 30 minutes period. I think it's quite low, considering I think UMA has been using normally 2 hours, um, and we are thinking to use 30 minutes. So I think that's going to be interesting. But basically, once a proposer puts the proposal and let's say 30 minutes have passed, we assume the proposal was an honest proposal. So the system will, the price model will continue working. But if there is a dispute, then that's where we raise the dispute to UMA. Mhm.
Hey, Edson, did you consider using another oracle, like a price feed oracle, specifically for the job? Uh, why why is the OO a better
Yes, so
option?
I think, I mean, there is definitely the possibility to get an oracle, but I don't know if there is realized volatility oracle today with, let's say, Chainlink. However, we are, this is for us an important piece because number one, we want to remove the more we can the pure dependency of oracles. So, the Cora protocol is actually very lightweight. Basically, the only dependency we have at some point is when the person wants to borrow, we check the price of the collateral, and then based on that we just verify the loan to value. So we say, okay, according to the oracle, the it price is 1000, you are asking 800, yes, that's within the LTV. So that would work. But what we're trying to remove is basically the full to add more Oracle dependencies in other parts of the system. Now we are also very interested in exploring this type of price models where you don't require real-time data, but data that could be 1 day old, and that should be enough. So as I was saying, one possibility could be to do perhaps an interest rate swap on top of Cora, and you could basically do that using UMA. Another thing would be to, okay, let's say we allow anybody to run their own lending pools, but then they need to maintain their infrastructure to basically update the values in their own pricing models. So what we are trying to create is a system that is purely decentralized, that I don't require any infrastructure or anything, that simply by putting economic mechanisms, economic incentives within the protocol, could allow the protocol to work in a very decentralized manner. Mm-hmm.
Excellent, thank you. And how far along the development line are you? And are there anyone actually
Yes,
using
so
it
right now we
now?
have the price model itself. Actually, the price model that we have is a hybrid price model that is combining Black-Scholes plus a fixed interest rate. And the reason is because basically Cora is structured.
Sorry, can I just stop you there? Maybe I'm the only one, but can you explain what
Oh,
Black
yes.
Scholes is? I'm not familiar
Yes,
with that
it's
concept.
oh, how do I exit? Okay, let me. Uh, so docs.cora. Yes, so let me see if I find it here. Yes, so Black-Scholes is a pricing model that is used in the. Let me make it a bit bigger. That is used in the options war, and basically it's a way to calculate the fees, and here we have the duration. So as you notice, as the duration increase, this is the time, the value that you pay is increasing. Okay, as you see, this is the shape of the this is the shape of the price model. So if you basically get a loan that is with more time, you need to pay more. So this curve is based on is the core of the Black-Scholes pricing model. So because Cora is a structured product, what Cora is doing is combining capital plus protection. Okay, and the protection comes from the option piece, the one that the Black-Scholes is using. So we have a hybrid price model basically that is using the protection part plus the capital part, that is the interest rate. Mhm. So we have actually we released the well, at that point, does that answer your question?
Yes, thank you. I just never
Yeah,
heard of that
sorry.
term before, so
I
thank you.
also guess my pronunciation is not very good, but yes. So yes, it's just a formula that helps you to calculate what would be the price. I think with this, what would be the price to charge, considering the probability that the if the borrower is asking this amount, if that price model takes into consideration the probability that the price will be lower than this amount. So that's why we are using these pricing models, and obviously the fixed rate part, because we are combining capital plus protection in one single product. We also need to compute that. So where we are today, we already finished the pricing model. So we have the fixed rate plus the Black-Scholes piece. Now the challenge is to do it fully decentralized, and we have started to draft the architecture. As I was saying, I was speaking with also with the core UMA team, so we are exploring the possibility to I mean, they said that it's a good use case. They found problems with the 30 minutes. They said that could be challenging. We haven't done it, with this. I think that it's called liveness period. So I think that's gonna be interesting. Liveness or dispute period, yeah. But yeah, the
Yeah, the liveness period. And why do you want 30 minutes? Is that kind of critical if it's 30 minutes rather than 2 hours, which is the usual
I
liveness
guess
period?
because I just thought it was good enough. No, that it's not super instant, but I thought it was okay. 30 minutes. Honestly, I don't have a clear reasoning behind that. I just thought that 30 minutes would be enough. But I'm okay having 1 hour or 2 hours. I think that wouldn't affect. We need to certainly do some simulations to see what would be the impact of this delay. Yeah.
Yes, and thank you ever so much for that. Just one quick note that I dropped the Wikipedia article to the Black-Scholes article in the text hub if anyone wants further information on it, because it's a bit of a weird spelling for people trying to Google.
Sure.
The question that I had looking at the fault tolerance is that you have a proposer and disputer, and then the dispute goes to UMA. So is there like a fork of UMA that the proposal goes into? Or is it being proposed in UMA itself?
No, to UMA itself. The idea is to go to UMA itself.
So you would propose directly to the optimistic oracle?
So we are not using the optimistic oracle because actually that's a good point, because that was the first solution we were thinking to basically the logic on which we calculate this value could be basically just be integrated into the optimistic oracle. And then the interaction that you would have is that, okay, the proposer is not really proposing, it's simply saying we need to update this price model, and then the price model calls the optimistic oracle, and there is a proposer. That's it. So actually that's something that we are also exploring. Why we didn't go that path, because the John from the core team was also telling us that this architecture can also be very interesting because the price model itself is living there in the blockchain, and he itself is exposing what exactly you need and how you want it, and basically let's say the ancillary data or any the logic on which you calculate this. And it could say, okay, if you want to propose a change here, you need to go to this, let's say, engine that lives in GitHub, or check this way to calculate the value, and then anybody can run it. But yes, using directly the optimistic oracle is something that we're also exploring, or following this architecture.
Okay. I bow to John's superior knowledge about architecture for these kind of things. It just wasn't very clear. So when somebody makes a proposal to update the price model, it would go into the Cora system.
Yes.
And then if it's disputed, it goes in as a proposal to UMA. Is that
Yes.
right?
Correct.
I see. Cool. So would the dispute go in as a proposal, or the proposal go in as a proposal, or is that just something that's
So
be determined?
the proposal, this proposal, basically here the proposer needs to put a bond, and then if there is a disputer, that proposal is marked as disputed. So the system, the Cora price model system, wouldn't take that value. However, the disputer can immediately make a new proposal, and then at that point we trigger the dispute for the proposal of this proposer. But as you notice, the disputer has already proposed a new value. So there is also the opportunity for also another disputer to come and make basically another dispute. So the idea is that the price model can continue working, but we already raised a dispute of this particular proposal, and the money that this user put like his bond is gonna be locked till the dispute is resolved. So basically, in that moment, we can settle who gets what. Mm-hmm.
So what would happen is that if a disputer disputes it on Cora, and Cora itself would do a request to the Oracle and proposal as one transaction. Yeah.
No, because when the disputer is yes, so the disputer just goes, makes the dispute, he can propose a new value too. So that's and yes, and then trigger the dispute. Yes, you are correct.
Ah, cool. Thank you.
Thanks, Vari. Anyone else has any comments or questions? No, that was very useful, Edson. Maybe you can just kind of plan out. Do you have like a little roadmap that you could share with us?
The idea, obviously, I didn't prepare a slide for that, but we already launched a testnet last 2 weeks ago with a community, the DNS Core community. They support us to launch the first Cora version. We got good feedback, and we basically improving the protocol. So right now, basically, the main problem is that we cannot really launch the protocol if it is not fully decentralized. So we need to either integrate the optimistic oracle or this approach solution. Mm-hmm. So I guess the goal or expectation is to have this prototype and I would say testnet version by the end of January, and run the first testnet in at the end of January with everything fully decentralized. Mm-hmm.
And if people wanted to get involved in this project, do you have any links or
Oh yes,
any information?
that's a good question. So we have the website is cora.money. Yes, and here we have a link to our Discord and also in our Twitter. Mm-hmm. Actually, we mentioned UMA in the introducing article. I think that was quite interesting. Let me see. Yeah, so the decentralized pricing model. This is really I think this is one of the main important pieces of the protocol. We really want to have fully decentralized pricing models, and this will include. I mean, we are really trying to work to do it with UMA. Mm-hmm.
That's awesome. Thanks a lot. Do you have any final comments, or does anybody else have any final questions or comments as well?
Just to say that if you had documentation, it would be great if you could drop it into the developer channel, Edson, just so that people can kind of take a look or drop some links. That would be great.
Yes. I actually am writing a proposal for the SuperUMAN DAO, because we want to, obviously it would be nice if we can get some support. So another thing that I think is very important to mention is that Cora is a purely decentralized and community-owned project. We haven't got any VC funding. We basically is purely on grants, and so I think that's something we want to basically point out. I think it's very important.
Okay, great. And with that, maybe we can finish there.
No, thanks to you.
Edson.
Thanks for your time.
Thank you very much, Edson. That was cool.
Thank you.
If you could drop some more info whenever you get a chance, so we can check it out some more and dig deep into it. It'd be cool.
Yes, thank you so much. I'll do.
Thanks, Edson. Thanks, everyone.
Thanks, guys.
Thank you, guys. Thank you.
Bye, guys.
Bye.
Bye all.